Hello and welcome to a new case. I had other plans, but Dim opened the race to first bring out a video about this case, so sorry Dim, I was faster, or hopefully faster, I don't know yet. In this case is Hydrosmash. It's an MECC case, it's the team finals case, and it's a hard case. A super hard case, one of the hardest I've ever done, if not the hardest. And therefore this video can get messy and will take obviously longer. Oh, I think it will take longer than 30 minutes. I've solved this case before and I know how to do it basically, but it will be messy along the way, either way. Yeah, and also it's like a team case, so 3 persons, 30 minutes, or I think 30, yeah, or 40, I don't know, I think 30. So 1.5 hours for the whole team. And out of the 2,000 points, the best team, and there are good students in those teams, scored like 600 points. So not even a third. That is how hard this case is and will be now. So, but without further ado, let's jump right in. And I will also do something crazy here. I will first do a few bonus questions. Otherwise, I do them at last, but here, every time something new. How many cells are in the Hydrosmash chord? I copy this chord here. I need it later, I know this. And then Control H, not Control H. Control H, yes, sorry, not Alt. Choose format from cell, replace everything what is a chord, and there's thankfully here a beautiful explanation. Here, what is all there. Why is it taking so long? Yeah, I don't know. Normally this should be quite fast, but I've experienced this since a few days. Some performance issues. So I don't know. Yeah, here we go. You need to replace all those squares with ones, and then I had to do a sum of everything. It could be potentially be faster to simple drag it, but yeah. You see, now we're getting faster. I don't know why this wasn't the case before. Also, this white one is inside the line, inside the course. Now it's faster. I don't know. Crazy. And also those blue starting cells are within the chord. 3 replacements. Yeah, also here. We don't need that. And then the sum of all of this is 2382. 80 points in. What is the most common cell address? So, I've imported also my lambdas and I have opened my esport macro, so full force today. We need it for this case, guys. Most common cell address. Normally I have there a lambda. We can use there CMV first direct. This is basically a bonus setup, or my bonus setup lambda and my count most of combined for like those instances where we need to have it super fast or have something super fast. But now I keep attention 1, 6, 9, and 10. What is the AT, AX, BF? Yeah, I think BF is the most away thing. BF 404. And only from the numbers 1, 6, 9, and 10. 1, 6, 9, and 10. Yes. Now this will take some time to calculate. Here we are. There's also some other stuff in, probably also, for example, those names, but we're only interested in the cell reference. And the answer was most common cell address, so we can take it here. And again, 80 points scored. This is like setup, it's also count fast, because sometimes, especially with like bonus knockouts, it could be cool to have something to like really quickly. It's like basically only two lambdas combined. So yeah. Now I like to have everything here, but I turn off the calculation. And here also dim. I think we talked about this at the finals. Here in the developer task under properties, you can turn off calculations for sheets. Then, largest distance between two cell addresses in level 6. And distance all the time here in this case is measured that the diagonals are counting as like going two places, so not like one. I think I've destroyed it. Yeah. Here we are. Those are all those references. Now I need a to call and unique, or other way around, sorry. Unique to call. Of all of this. And then this here to row. And then I use my distance lambda, distance between cell reference, or one of my distance lambdas, to figure this out. Yes. Diagonals are counting as 2, yes. Now this will take some time to calculate. You see here. Is this unique? Could this be the case? 400? I don't know what I did here, but I think we need to go down that rabbit hole. Yes, don't show again. I know. Hopefully this will not break. 0%. Oh, guys, this is also with this case. I did in my attempt. As I've said, I've solved it once before. So MECC 63. It will get messy if you don't turn off and on like calculations, because I do later on a lot with data tables. Otherwise, I don't know. I hope for a single cell approach from a bow, but otherwise this will not be cool. So I normally also have this here bonus direct thing for characters, but I think it will get messy when I have here multiple, because I could use this here for this bonus 4, but it would be messy, or will get messy with other stuff that is in there. For example, here those letters. So sorry, 6, 5, 6, and 10. Therefore, I copy those manually. Also, another thing, please MECC, get away from doing those kind of stuff that you have here, the header over 2 cells and then this as a merged cell. This is horrible. Please, you will hopefully will hear me. It makes things a lot harder, and nothing that is like showing Excel skills. And then 10. Here, for example, those are like then 2 things you need to pay attention for, or like 2 columns, or 3 in this case. Could be 2. So, and then most of char and area, I take it a large data set. I don't know if it will be needed. I don't think so, but you never know. And it's on purpose non-case sensitive. So no, the default is non-case sensitive. I think I need the number. How many times? Yes. And I could do this also without those lambdas. I did in one of my attempts. So I tried the case once, and then after a certain time I was stuck at level 8. And then I retried it with lambdas, and this is the real one. So this we can't do because it is related. So then also here, this level easy, I don't know about this. So this is therefore you need to know at least the indirect function. And yeah, knowing this function is like not that common when I think of other stuff. So certain amounts of difficulty decisions here are weird. So, but I know the indirect function, but the indirect function with a separate sheet can spill. So I need here a map. I have renamed this with a shorter answer, otherwise we would need here those special thing here if there's a space in between. And then forgot here the lambda. So I map in here every cell reference, close all the stuff, and everywhere where we are in the chord, there will be a number, as we did with this bonus replacement stuff. Therefore, I can simply sum this up. 30, yes. Put it in here, and then drag it down. Done. So here it's getting a little bit tricky, or not tricky, but because I have arrow lambdas, it's simple, the movement stuff we did before with lambdas, but in this case they are not given in an array as I would need it for my lambdas. They are given as a merged thing. But we can get away with this stuff. Where is this? Here we go. So text before this stuff. Yeah, we can work with this. No, I think I need here cell reference based on the reference and arrow array. And here the arrow array we now need to do. It's an haystack of text before. Will this work? I think so. With two delimiters this should work, but let's check. And please Excel do a mode where you can leave a cell without stopping the formula edit. So this is then the first location. So what I simply do here is splitting this cell into two cells, and then right of this len of this minus len of the splitted stuff could be in a lambda more beautiful, in a let function more beautiful, but here we are. I know, as I've said before, this will not be the most or the cleanest approach. Something broke. Make those references non-dynamic, and we can track you down. Medium be too hard, so here we need to first. Yes. So this is basically a scan approach. So lambda and scan can also work together, or not lambda and scan, arrow and scan, because here this is then we're at a new position and we are going from this position to here with a new cell, and therefore scan is here the best approach to handle this. But let me therefore copy my lambda here, because, oh, not my lambda, but this part here, because I've used it. Scan, this is my initial start. This, so this is the array lambda AB. Sorry, I used these letters and I know what they mean because they're always A and B. And then this reference will be every time the reference from above with the scan function. Was this right? No, I think this should be B. Yeah, this is the problem. Then it's Excel is changing the colors with like intriguing me when you replace the stuff. So, and now we have, when this will work, we have those positions where you are. And now we need to check two things. And this took me a while to figure out. We need to check if the play was or is on a different on the opposite side and inside the course. And therefore I use here a let. So these are my addresses. I later use or now use. And first we are searching in court. In court is map a indirect. Guys, sorry, I'm switching currently keyboards between the US and the German regularly, so some stuff is, or quite a lot stuff is different, and therefore I'm sometimes mixing those typing stuff up. Uh, um, Sorry, it's late. I hope I can do this until I'm finished with this. So now we have if it's in court, if it's a 0, then it's out of court. Now we need to check if it's always on the opposite side. Therefore, we go back to our addresses. And now I'm think I will do, because I need here the column number. Will my column no, the row number from cell reference. Will this spill? I don't know. Yeah, it will spill. Okay. Therefore, we can also use this. That's great. So here we take name R, row number. It's simple and indirect and an row, I think. I don't know if this is with an map function also. Let's find out. Row number, not rotate. And sorry for this exploration stuff. I take the time I want to take, and if I lose some of you along the way, sorry for that, but this should be fun and not only Excel like doing hardcore. So R, and now I need to map R and, or I want to map it, I don't need to, I think. Drop R and have is it because I'm not including the starting position, but it should be alright. Yeah, and drop R, the first column, lambda A, B, wow, guys, sorry. And now I use an if-else, if-else, A, so, sorry guys, there was noise outside. We are map in R if R, this first is larger than 35. if runway, we can do this. If the first is larger than 35, then if the second is smaller than 34, we are alright, otherwise we are not alright. And here if the first is smaller than 34, oh no, if the second is larger than 35, because this is then smaller, we are alright, otherwise not. We can close this stuff. And then we can, I think we can, 84th, yeah. We can multiply this with in court with IC, and then do an X lookup for 0 in here, returning the addresses we have stored as A9 is wrong. Great. Why is this wrong? Now the debugging begins. The problem is also, well, not a problem, but the thing is that this core case isn't that clearly that you can't go from there to there, and so the fourth is in, fifth is out. I think I see why. Let's check. So I see this is the thing that should be out. Here this is out due to this constraint. Let's check if the map thing is alright. Okay, here we're going out once before, but I think here I need to, yeah, a stack there one in because I'm dropping out also the first position. But I think, yes, and then this should be result. This will give an error because I need to then drop out the last one. The last column, because I also have there an error because I has dropped out there something. And now this should be right. Oh, it's wrong. Let's test this out. It's wrong on some occasions. Have I data tabled it in the last one? Yeah, I did a data table. That's too early for a data table. I think I should have done the data table here. Yes. First check those side stuff. Yes. Yes. Yes, should be alright. Now let's check why this E isn't working. There should be an R. So first I want to have the addresses. Do I have even A here? You see, buggy. R50. It's here. I see in court. So I think the middle part is the most easiest of this case. In court, Oh, yeah, I know what my problem is. Dumb. No, I need, because I only want to drop and stack. Oh, this was a bad thing. I hope that I can heal it. I only want to drop and stack this second map part, not the IC part. That was a wrong error, but at least I would have found out here. And then drop. So haystack is alright. Drop out the last column. Return A, and output is result. Now it should be A. Ooh. What is going on there? A. Wow. This calculation speed is alrighty. IC should be fine. I should not do this like at 11 in the evening. I need to, of course, stick in here a 1 and not a 0. Otherwise, I've always result 0 here, and now it's alright. Yeah, everything fine, and I also did this in a single cell approach, better than in my last attempt. So, here, this is also not an easy thing because you need to at least calculate the cell difference. Distance between references, there are two references given. One is AA19 and one is AA50. This cell reference cell distance lambda can do this for multiple references, and then I take here the minimum. So at least in one direction for multiple references. The starter reference needs to be constant, and this needs to be at least, or can be one or so multiple. It's wrong. Yeah, of course. Should have checked because here diagonals are counting as one. I should have checked this with the example, but now we're fine. Now, how fast are the players? What is the maximum number of plays that specific players can move in on a particular turn? Because they have an initial speed and a fatigue factor, so it's basically a linear function going down from a certain point. So, and it's simply 2x lookup. I don't know, I think this is basically harder than this. This is basically only 2x lookups and nothing else. And for example, a sequence also, but sequence is basic. So I don't know. So here, this is the formula. It's the initial speed multiplied with the fatigue factor at this turn stuff. But I think there's a catch with like starting from the above, because the initial speed is like basically the speed from the calculation above. So in this case, turn 7 would mean 6. The fatigue would be going in from above from the turn before. No, -1 multiplied with xlookup. Not, oh no, here isn't there is not even a sequence function needed. So yeah, I don't know. This is more advanced, less advanced than the level above before, even with my lambdas. So this should be now all right, but let's check at the example 20 here. Yeah, 22. We can track this down, make here a clean approach. So now it's getting a little bit more tricky. What is the location of the first toss that the player cannot catch. And therefore we need to have like the distances between those cells, and then the calculations, or like how far they can go at a different thing here. And I think I will try the single cell, even if it's not that easy, so to say. So I drop in here first, I make the distances, drop the first column, lambda a b distance between cell reference a, b, and now I know they're also counting as two yeah, here I have the distances, and I now need to check I think begins at a. I'm delayed. A stack AA19, and then dropping the last out. Sorry, I have missed that here. This player begins at A19. I stick this, close here the bracket. Yeah, here we go. Here you see 37 is the distance at 08. And now if this is larger, then I think I bring in here this stuff. If this is larger than this formula here, and we adjust this for those names. Now again, those nasty merged cells, and here I bring in a sequence for columns, I don't know, 30 or something. I think it was 30. Yes, and now we're searching for the first true and then handing out this here down below. XLOOKUP for true, in here, returning this here down below. And I know this is not the most clean approach. For example, here this as an input here in a let function or something would be more beautiful, but yeah, this will not be the cleanest approach ever. So now we can track this down. Level 6 gone. Level 7 will be also doable, but afterwards it will get messy. I can say that it will get messy. So where does the player and their movement after catching their toss? So, and I will do this two ways. First, I will do the data table approach. Level 7, yes. And I know I don't have a robot command for creating data tables. Sorry for that. And this data table stuff isn't working cleanly on MECC cases, because they are sometimes different to the MAWC stuff. But at least the numbers and the example stuff and the answer is written here cleanly, but input stuff still sometimes problems. Could also be because of the merged cells. So movement and toss location. Now, I also take in the explanation. I know it basically, but probably you will read a little bit along. Put it here. So the player is starting always at A19. The maximum movement is 30, and they go to this location, and afterwards they're going back to their original location, but only as far as they can move, and they're going first horizontally and then vertically. So how do we do this? First, I want to have the distance in vertical and horizontal stuff. This was one of the first lambdas I've built, and it's one of the most useful if we have like different distance stuff. For example, in the boba case, deep sea diving, it was also super useful. So it will simply print out the distance as an array in first horizontal and then vertical distance. Then I want to have the absolute distance of this. And then I want to know how much is left. So this minus sum of this. 7 is left. And now if this is larger than this, then only this, otherwise this. That we can only move that far, and if this is larger than this, then this minus this. Here, this is the thing left, otherwise 0. This is horizontal and this is vertical for your explanation. And now we need to check. So if this is positive, then I need to have minus of this, otherwise this, and also here, because my not this. Should have checked minus of this. So minus of the actual movement. Here, this is fine, and now I can use the cell reference based on reference and movement lambda. This is my starting location because this is the location I'm at then at this point. In this column, we first move horizontal and then vertical. And then we are at AK13, which is the example, the given example. And now we data table this stuff. This is severe earning so slowly, I don't know. Too slow for my thoughts. But so, and now we have something is odd. 124, why is this wrong? Can they overshoot? I haven't paid attention to this or haven't experienced this last time. Okay, what should... this is not the best approach, but what should be the answer then? Because otherwise I will lost you as a viewer if you're not away anyways. AA19. 124, I think. Yes, get away with this data table. 124. Why aren't you calculating? So AA30. AA19. No, here we go. Reference AJ16. The still left is 23, so we should be comfortable going back. Yeah, I see. Here I should have a min I forgot about that. I can also use here min of this and that. And here I should have a min of what's left. No, a min of this calculation and what we actually need to run through this. Sorry, I forgot about this point there. Yeah, now we're talking. Wouldn't have been that impactful, at least here. But here, sorry for this. I missed that point. The instruction test we can overshoot because here we are overshooting because we have 35 movement and we only need 2 times 12, so 24. Yeah, now everything is all right. And what I will now do is something a little bit different. And I would not do normally. I would be out as of now. But I will do now an lambda out of this because we need this probably later, or we will need this at the later levels. And therefore I will do a lambda based on this stuff here. So lambda, I never did this before, so create inside an competition a lambda, but every time is the first time. So M for movement, and this is the cell we want to get back. So a 1 will start and L toss. And then a let H3 is basically I'm doing all the stuff in a lambda. I could use here, for example, probably also lambdify if I would have created this beautiful or a robot, but I do this from scratch. I take the time here. You can also get to the next level if you want to jump here. H3, because there's basically nothing more than seeing me struggling here creating this lambda. So now I also build this real life test that I always have those outputs. Here, this is all right. Get away your data table. ABS. And yes, you can name as a function. Left. Where it is at least small m minus sum of ABS. Three. MBH movement basis. Horizontal is minimum of at, so intersectional operator of ABS, and left MBH, basically this figure, and this is I copy in MB movement basis vertical is the minimum of here. This should be left, this should be left, this should be at ABS, not Q. Too much keyboard changing. And this is drop ABS first column. Here, I know this should be MV3. Yes. So now movement horizontal. And yes, I know them, this is not the most beautiful thing, the input should be at front, I know. At HV, and this is MBH now, this also, and this is MH. Now we can also movement vertical, copy this in. This is then drop HV first column, and this is movement basis vertical. Yes, and then we can build here our cell reference based on reference and movement array. We are going from the toss, movement horizontal, movement vertical. It's the same, and we can now also make this a real lambda and name it toss. Now, let's test. Toss movement is given here. First is A19, and then we can work with this later on. So now it's getting tricky because first you need to understand what is going on. Or you're like a better reader than I am, which is not that hard. So we're going from AA19 to the first toss, then back to AA19, then from this toss to the second toss, or as far as we can go back, and then to the second toss. But from the second toss, we are not going back to AA19. We are going back to, we're not going back to AG6, we are going back to AA19. And here we're going back, and here we're going up there. And what I first thought, what I can do then is use my toss lambda, and always we can go in every of those tosses, we can go 30, so like the movement length. What I first thought, I can use here my movement thing, lambda stuff I've created, and simply stack it. So like use then this as an input and this as an output. And this will work for most of it beautifully, or surprisingly, but not for all of them. So we need here a second lambda where we start from a position, going to another position, and then going back with the left stuff to another position. So we can use most of those parts here, but a little bit more stuff will be needed for this toss2 lambda. How do I want to do this? I think I will data table is. So data table level 8, sorry. And we're still at 50. So I think this will be a little bit over 1 hour. Because the later stuff with this preparation will be a little bit easier. So look up for this example in here, returning all this stuff, even if the formatting is shitty. Sorry, not the best. I want to have this here. Here we go. So now, first, after the first toss, we are always starting from A19 and then going there and then going back. After the first toss, I'm at AA 11. Let's copy also those instructions in. And I didn't knew because here it's only reference to a starting and ending position if the ending position is like the initial ending position, starting position. But in the example, it's then described. But first I run over these, as always, you know. There, then I want to have the distance between cell references. This is the first cell reference. This is the second cell reference. They're counting as 2. Then what is left is 14, and this 14 I can then go back to AA19, so the initial starting or original starting position. Yes, and therefore I need this distance between cell reference 1 is this, and this. It's 0 and 8. Could this be alright? Sorry. Player begins maximum movement. Then he's at AA11, which is alright. And then he needs to go to this. From AA11 to A0. Is it alright? From A to O. Here it could be 15. Yeah, should be fine. Here, 16. But is then the distance between... I'm dumb. I need to know the distance between this and this. That was my problem. Guys. Guys. ABS of this. And then I can basically use what I used here. Can I use this? No, this is then the remaining stuff. So this is then 14. I can then go here 14 and then going from A to this should be BC. No, this is wrong because here I did this switched. If I switch this back, it should be AA9. Yeah, it is the answer. And now we make this again a lambda. So what is my starting position? This is alright. We don't need this here. We need this here. And this is... The question is, do I have the first toss position in there? Here I have. So lambda M for movement, original starting position, T1, oh, what was it before? LS and LT. L, I don't know why L. So now I let rest, or it's the rest is called remainder in English. Sorry for that. I'm sometimes thinking German here. Minus, but also Benny sometimes speaks German in his video. So Benny, the clamor is bracket, but I also forgot sometimes about this. And distance between cell references, between... I'm a little bit lost. what will then be? I need to think, guys. Cell reference 1. And I need to translate it into LAMBDA language. This is so L1 and L2, yes. So LS and LT. One here and putting out this. So also here movement is 30. Original starting position is AA 19. I'm starting there from my first toss to the second toss. This can then not be right. Then I need here, instead of this, I need here toss 30 LSLT. No, it can't be right. 19? Oh, guys. This 30 distance between cell references. This is the first toss. Yeah. This is then OSP and this is LS14. Yeah, we're in the game. We're in the game. And then distance between second toss and original starting position. DT. This tenths. LS and OSP. Is this alright? 2 second toss here. And the other way around, please. Then ABS. From distance. I think we will need longer than 1 hour. And then minimum of, so to have here the movement horizontal, or the first initial movement stuff, a minimum of at ABS and remaining stuff. Yes, I know. Output this, and then for vertical, movement vertical, it's this is drop ABS 1, and this is at BS. Movement vertical here, and now horizontal. At dt is larger than 0 minus movement horizontal, otherwise positive. Movement horizontal minus 14. And also here vertical. If drop distance 1 is larger than 0, movement vertical minus, otherwise positive. Let's check. And now cell reference based on movement and arrow and reference and movement. So now my reference is the second toss reference and the movement is horizontal and then vertical. S9 Yes, I think I need to turn on here differently. Guys, second toss, horizontal, vertical. And this, again, second toss, toss 2. And then I also do not need to switch here the sign. AA9. Yeah, here we go. And this is then toss 2. We can then use here. And now toss in here. We're starting in AA19 and then going into this toss here. AA19. Is this working as it should then? Oh. We can, I think we can also use here only toss 2. Yes, should be fine. I've even optimized my, no. Yes, I think because this is original toss. Here, I did it as before, sorry. Sometimes. Yeah. That's super bad. It's worse than before. Debugging after 1 hour video. It will be probably 1.5 hours. And I did it also differently than before. So do this at 142. This isn't the answer. So 1312, then going back 1, A13. Yeah, A13 is right. Can be right. Yeah, it's alright. Okay. Then there's something odd with my lambda. But this is then working on this live. Okay, let's try it that way. Movement, original starting position, AA19. First toss, second toss. Wrong. Okay. Is there something I've missed here? You're only referencing to those cells. Oh, yeah. Original starting position should be in here. Of course, it's wrong then. Yes, toss 2. Now it should work. And I have optimized my lambda. Ooh. Original starting position. What is going on? Okay, I should have checked because there were entries here. Okay, we're getting first a. Oh no, this isn't OSP, it's movement. Okay. Guys. And now, and then we do not want to have the distance as an output. We want to have the cell reference based on movement. And we're going from the TOS2 to horizontal and vertical movement spaces. A13. This can be right. Can be. Yeah, it's right. Yay. Level 8 solved. Messy, but at least we're a beautiful lambda. Now it's getting tricky that not even single cell. Trying single cell is the way here. Trying this single cell in combination with a data table is the way to go. No, I do not want. Okay, now I have my lambdas here twice. Sure, sorry, I clicked the wrong shortcut. And I think this is then messing up. No, not messing up the name manager. I wanted to click Control-Shift-D and not Control-Shift-L. So data table for level 9. Go down here. XLOOKUP. In here. Returning all this stuff. And here this is always like A and B alternating, but we're starting with B and then with A because the toss is for a different player. And we wrap this. I think the length is always the same, so we do not need to pay attention here. Okay. So movement, all player B is starting in AA19, player A in AA50, and they're playing tosses. And therefore we use the toss, not the toss2, the normal toss lambda. Movement is given here. This is for B. So this is B and this is A. Sorry, this is messy. Probably make this white. So at least this. So track this down. Here we have some value errors. I don't know why. Okay, no, there should be value errors. And the question is, movement from 8. So I should use toss2 here. The original starting position is A19-2. So I could use also here this and 4. So no, yeah. And then copy this formula here. This is for A, this is for A, this is for A, this is for A. And what I now simply do is trying if the distance distance between cell references. This is the first reference and This is then the second reference. No, this is then the starting and this is the goal. If the reference is larger if this is larger than a stack this, then hand out the reference here, otherwise an error. And then I toggle this with these errors, and those errors are getting ignored. I wanted to have 3 entry. And then my result is always this cell here, and I can data table it. And now you see why I did those lambda stuff. This is calculating for quite a while. I don't know, somehow the performance isn't the best with those workbooks. This should be now. Oh, we get an error. The question is why. So 169. Get away with the data table. Oh, do we never reach the boundary? This cannot be. It seems that we never reach the boundary. This is weird. This is weird. Weird stuff going on here. Okay, let's check again. Those wrapped stuff. 169. Those is this wrapped stuff. And then we have here a and this seems alright. Here we have those distances. And we have here for example distance between this could have be costly. Yeah, I need to make this non-dynamic. And now we are not getting a result again. Is this the right distance? Oh, no, this was all right. This was all right. But here it's A and B switched. Oh, so this was all right, but this is then this distance, and this is. Sorry guys. This is this distance. The switching sides thing is weird. So here we go, and here we get AG18. Could this be? So again, no, this was right. I'm getting confused. I'm getting confused, guys. Diagonals is on. Okay. Diagonals is on. 40 is the way to go. Is this lambda not working? That's the question. Probably TOS2 isn't working. We're always getting back to the original position. Always getting back. Movement is also okay, there need to be a catch. I'm not seeing currently. Is TOS2 working right here? Here it's working all right. But here A50, can we go back there? That is the question. We're going to 66. From 41 to here. It's 29. So we have 11 left. And with 11, we cannot go back to 50 from 66. So is there an error in TOS2 lambda? That's the question of the questions. Edit lambda world would be nice, but I don't have it on this machine. Sorry, Eric. Or I should be sad then. Crazy stuff. I think TOS2 is somehow not working properly. We are nearly at 1.5 hours. In the other attempt it was good, so TOS2 was working, but I have built it a little bit differently. And yeah, so movement is 40, original starting position is this, the throw before is this, and then this is our goal, M36. Ah, no, I want to check for this here. So A50, can this be rest? It's 23. And the rest is TOS M is movement, OSP, and LS. And LD. I think TOS2 is not the right for this. TOS M is move. This is alright. Movement, original starting position, LS. I should never use that naming. It's nearly midnight. The question is, what is wrong there? Is my thought process wrong? The most obvious choice. But of course, this is broken for some stuff. As here, we're going. We're going here 29, and we're going this path. But we have only 40, so we can't go back all the way. TOS. Yeah, TOS is given. This isn't. I don't need here TOS, I need here LS. Here, and then it's 11. I don't know why it has worked. So, therefore, I think it was alright for this level, but for the level above, but since I wrote it a little bit differently, it isn't the best for this level. Okay, there's nothing changed. That's bad. Okay, this is 56. 56, 50, 36, P and V. Okay, there is something odd. Because here, this is larger than 40, right? 46 is larger than 40. What was? Huh. Okay, now it's working. I think Excel is also in the sleeping mode. What if analysis data table? Now it will hopefully work, fingers crossed. Oh guys, nearly 1.5 hours. Sorry, then your video will be shorter. Now, let's hope that this is alright. Yes, here we go. And now level with our pre-built stuff, level 10 will be easy. If I can copy it properly. I also should now here we go. Hopefully turn off here the calculation. I don't know why this is taking that much power. I know I'm using here data tables and volatile functions, or my lambdas have volatile functions. That's hard, but shouldn't be that hard. XLOOKUP for example 10. The format should be the same. Is an no, it's a few inches, few cells longer. I don't need this. I don't need this because I know that this is then with those fatigue syndrome stuff. So this stuff we've calculated. This is horrible. We've calculated here. So let's copy this in. I want to search for this person. And one time search in here, returning the initial speed, and then search in there, returning the fatigue factor, and then instead of this cell -1, I need a sequence of, I don't know, 20 rows. And do I need here? Yeah. Either -1 or starting from 0, because the fatigue is not at the first turn, only going on or starting at the second turn then. And then instead of this absolute, we have this now dynamic, and this is also dynamic. And then if this is okay, and this should be then larger than this or than this. I hope the sides are correct. AQ29. At 24. It could be alright. Where is... build this from scratch. Sequence 20, 181. Wow, this will now calculate a lot. Guys, but we can check J26, J26, and H8. H8, yeah, I think this could be right. But this data table and volatile function stuff is breaking Excel's neck. I should remember some Excel jokes for that occasions. But here we are. 3, 2, 1. Calculating. If Excel is broken down, then now can we be under 31 minutes? Oh, no, we're too late. But at least in like around 90 minutes, we've solved this case and everything is right. I hate this data table approach, and also those LAMBDA stuff was a little bit more messy than initially expected. But here, such is life, such is Excel. So if you are currently at this point, one bonus question. This is simply 1, 4, and 7, and 7 are the rows. I nearly forgot about this. Rows of, or row of indirect here. Yay, now we have like full points here, average of 1 in this column. So thank you for your attention. If you're at this time with me, or add a comment in the video description, then you will get bonus points from my side. Thank you for your attention, and thank you that you stayed with me for 1.5 hours. See you then. Bye.